Okay, so for section 2.8, we're going to be studying the derivative of a function as a function. So as we know from the previous section, the derivative of a function f is the limit as x approaches some particular value of the difference of the y's divided by difference of the x's, or in the equivalent definition, the limit as h approaches 0 of the difference of the y values over h. So the idea is that the derivative of a function is always the value of the slope of the tangent line at every single point. So for example, I have point A. I have only highlighted a few points on the function, but the same thing happens to every single point on the function. Remember that there are infinitely many points whenever we have a curve, so for every single point that there is, the same situation happens. So I'm gonna draw the tangent line to A. As I mentioned before, I have my little car here. So if my car is situated at point A, the path of the lights coming out of the headlights from the back and the front are going to be the path that my tangent line will go through. So just to give you a visual representation of this, this is where my tangent line will go through the point A. Okay, now this line, maybe I'm gonna use marker here. This line has a slope, and I appreciate that it's a negative slope. Okay, I could find the slope if I have 2 points on this line. If I know the delta y over the delta x, then I know how much that slope is. But at least I know that it's a negative value. Now for point B, my little car is gonna go. Okay, point B is right there. The headlights, the lights will go through this path, so my tangent line will look something like this. I'm exaggerating it and I'm going kind of out of the point, but you get the idea. The tangent line will go, or will be inclined as this line. Now I'm gonna draw my slope triangle. I have a difference of the y's over difference of the x's, and notice how now the slope here is different. This one is more inclined and this one is less inclined. So as a number, let's just eyeball what this slope will be. Remember that whenever I have a line that is at 45 degrees, the slope is 1. So this will not be -1, this will be more negative than that. So let me estimate it at -5. Okay, I don't have really any units, so I can't really estimate it, but I know that if it's at 45 degrees, it will be either 1 or -1. Since this is more inclined than -1, let me say that it's -5. Now, compared to this one doesn't look as inclined as -5. It's less inclined. So let me say that this value, it may be -2. It looks kind of like 45 degrees, so it may be -1. I'm not sure. So this is slope -1. This is slope -5. Okay. We have to develop this number sense about the slope of any tangent line, because this is something that is going to be helpful whenever they ask us to sketch derivatives. Now, what happens at C? So my car goes from B to C. Notice how the lights, the inclination is going to change as I'm moving along the path. So it's not like I'm changing from -5 to -1 abruptly. I'm changing continuously. So at C, what do you think the slope of this tangent line at C will be? You are correct. Hopefully you are correct. The slope is 0 there. Okay, so it was very negative before, less negative, less negative, less negative, until it finally reached 0 right there. So what's going to happen when the car reaches point D? What happens when the car reaches point E? In point E, I'm hoping that it's easy for you to see that the slope will be 0 again. So between these point C and E, where the slope is 0 and then again is 0, what happens in the middle? Well, let's see. The slope is 0 here, and now it changes value. You know, it's gonna be, I don't know, 0.1, 0.2, 0.3. Well, I can't really say what's the number next to 0, but you get the idea. It's gonna be growing, okay, up to D. And then what happens from D and on? Okay, so let's see it again. The slope here is 0. It's gonna grow, you know, 0.1, 0.2, 0.3, 0.5, 1.1, 1.2, 1.3, and then what happens after D? 1.1, 1, 0.9, 0.8, 0.7, 0.6, 0.5. Okay, so the slope in here all along is positive, but it's gonna reach a maximum value here. Like the slope is gonna grow up to here, and then from here and on it's still gonna be positive, but it's going to decrease. So I don't know, let me estimate this slope at I don't know, the diagonal of a square is 1. Let me estimate it at 3. It could be 3, it could be 4. So now the slope is again 0 of this tangent line. Now what's going to happen between E and F? So the car follows this way, and then the tangent line is going to look like this here. Let's estimate it. First of all, is it going to be positive or negative? And you're absolutely right, it's going to be negative again. Now let me compare the slope of this tangent line here and here. I don't think it's as steep as A or B, so I'm going to have to choose a lower value. Not a lower value, a lower negative value. It could be negative 1/2. Okay. Now what happens here? From 0 to negative 1/2, it decreased, right? 0, negative 1, negative 0.1, negative 0.2, negative 0.3, and so on. And then from here, it started increasing again until it reached 0 again. Now this is the way the slope of the tangent line changes depends on the curve. So for this curve, I'm tracing this, but for a different curve, it will be different values. So after G, naturally my slope is going to increase. Let me show you H. At that H, it is very steep, it is very inclined, and it happens to be a positive value. So I don't know, I want to say slope is 10. Maybe it's 20, I don't know, but it's going to be a high number if I compare it to the slope of 1, which is always like this, 45 degrees slope of 1. Okay, so now I get the sense of how the slope of the tangent line changes. Okay, now look at this. For the point A, I have the derivative, or the slope of the tangent line. Please don't make me say that again. I'm just going to say derivative. The derivative at point A is -5. The derivative at point B is -1. The derivative at point C is 0. And so on. Okay. Point A, remember that it has some x and y coordinate. B, some x and y coordinate, which I really don't care about it right now. I'm just trying to develop some sense on what does the derivative as a function look like. Okay, so every point has an x and y. Okay, so let me pause for a minute. Okay, so I have a coordinate plane with x and y axis, and I'm gonna graph the derivative of f, or better known as f prime, which is the derivative of f, and I'm gonna graph it as a function. So for this x value that A has, the derivative is worth -5. So I don't know where A is, but I'm just gonna say that this is the x coordinate of A. So I know that the derivative is worth -5, so I'm gonna place that point there. This point is the x coordinate of A and f prime at A. Okay, that's -5. Okay, now for point B, the derivative is -1. So now at the same distance from the y-axis, I have point B, and now the derivative is -1. Now point C right here, for point C right here, the derivative is 0. And then for D is 3. And for E is 0 again. And for F is -1/2. For F is -1/2. For G is 0 again. Okay, so this is G. So what happens between -5 and -1? The slope change, the slope grew as a value, you know, -5 is lower than -1, continuously. So I'm not afraid of connecting those with a curve. Now it's not going to be a straight curve, you know, make it wavy, but not crazy wavy, but it's not going to be a straight line. Don't think that it grows constantly. Now what happens from -1 to 0? The slope, you can see that it decreased. Where's my car? Right here. The slope decreased until it became 0. So with a soft curve, it became 0. Okay, so what happens from C to E? When it went from 0 to 0 again, it went up, it reached a highest value, and then it went down. As you can see here, let me go back to my little car. The slope is 0, it grows, it stops growing, it decreases, and became 0 again. Oh, it came up. Okay. It grows, it decreases, and it's 0 again. What happens between E and F? It's 0, and then it decreases, it stopped decreasing, and then it became 0. So that's the little hump that you see here. It decreased as a y value, and then it went back again to 0. So this is, ladies and gentlemen, the graph of the derivative of f. And it has, visually, you will learn to interpret the connection between the graph of f and the graph of its derivative. But notice how little has to do with the y value in here. For example, all the y values for points A and B are positive. It doesn't mean the y values in here are going to be positive. You have to see what is the rate of change in this area. Like the rate of change in here is a negative value. So you know that the y values for f prime are going to be negative. Where do I have zeros? Not where this line is crossing the x-axis anymore. It doesn't have anything to do with that. It has to do wherever I have a minimum value or a maximum value. Okay, in here you have a relative minimum, in here you have a relative maximum, and those are going to be the points where we have a slope 0.